I've been into flat Earth since Sam Gerrans indicated the Earth may be flat according to his interpretation of the Quran. I'm stuck on your theory that east is towards the equator, though. Okay, I'll show it to you again. So the main point there is that east and west are circles. Okay, it's something that's not taught to us at all for some strange reason. I guess it's not that strange, is it? Yeah, Big Pine Sailing. Check it out and see what you see. And I can bring up my video too if you haven't seen my video. But and both times it was once I learned how to do it, it came within 2 or 3 seconds of the time that it says. Okay, which is pretty crazy. But I certainly don't think there's people in there. They fake it too much. Now, east and west are circles because of this. If you're down here, let's go to Fresno again. Where you at, Fres? Bakersfield, armpit of California. Fresno should be right here somewhere. Am I blind? All right, let's go to Bakersfield. Whatever. So if you're down here in Bakersfield, okay, and you're on this street, let's say, and you want to know which direction east is. So we grab this little thing here and we pull this in and we're going this way. Okay. So you'll notice that this street pretty much runs exactly east. You'll see. Oh, can you see this? I don't know if this shows. Oh, it does. Okay, cool. So you'll see what I'm looking at here. I don't know if you, oh, you can. So we're looking at this heading. Okay. So this street runs east. Let's draw this line out a little bit more. Okay. And it gets to about there. Okay. So that to you is east. And if you turn around and get behind that line and look in that direction, okay, that's east. At least that yellow line, not where the road turns, but okay. So very locally, east seems very straight, and that's all we know. And so people think, oh, yeah, east is just straight. Great. Fantastic. And you might say, if I told you, because somebody told me this the other day, you said somebody east of me is not west of them. Okay. If this person then wanted to know where you are, and we start the line there, let me just save that. Okay. Now we're going to draw a line going back this way. Okay. So now if that person's 90 degrees east of you and they're checking back this way, then guess what? It's exactly 270 degrees the opposite way, right? So east and west locally are no different than north and south. So we can look at this and know right away that this 204 runs north-south, right? We can then save that. And we can grab this, stupid thing, and then run this. And we know this is going to be going 0 degrees north. And then if we did it going the other way, south is the same, okay? So on a local scale, east and west are kind of like a compass with a, a cross or, a cross, a plus sign. But what people don't realize is that if you kept drawing this line out, so remember, this was 90 degrees east. But let's start drawing that line straight out, and let's see what happens. So if we keep our heading up here, I'm going to keep my heading at 90 degrees. Let's scroll way out, and let's draw this line at 90 degrees. You're going to notice something weird, that 90 degrees is always towards the equator. Okay, 90, there, whatever. Okay, this line is lined up to the equator. Okay, so is every east in the world. Okay, so no matter where we go, it's the same thing. Why? Because east is actually a circle. In order to keep going east, let's get back down to Bakersfield. Remember that if you started going here with your compass, that it's going to constantly adjust. You're going to have to, now watch this line. This white line, which they call the latitude, right? The latitude is a circle. Watch the white line. It's going to deviate from the yellow. See that? Deviating. Why? Because it's a circle. It's going this way. We're now nowhere near the yellow line. And if we kind of zoom out, we'll see the east line goes around the Earth in a circle. Okay. So you'll notice that these lines are east-west. So east and west are circles. They have to be. Otherwise, you would not, your compass doesn't work because your compass has to adjust.
Yes.
Oh,
yes. Yes. Yes.
Somebody clip that out, please. As thank you very much. Hexagonal Plane bought 3 smoothies. Thank you very much. You the man says, scared the shit out of me. Thought somebody was behind me about to attack me. So where was I at here? Another way of looking at it is simply with a circle. If you were to take a circle from the North Pole and draw it out, well, of course, this is always going to be a circle. Some people, and like the guy I was talking to with Brother Sanchez, think that if you flew on this line, that you're flying straight. I'm like, what do you mean? That's a circle. You're turning. And they're like, yeah, but you would never. I'm like, no, you would never notice. Guess what? You wouldn't notice that you were in this circle to be honest with you. Let me show you. Whoops, gotta clear. You wouldn't even notice this circle. Will you stop doing that? Hello? Okay, thank you. So, I mean, you wouldn't notice a 20-mile circle, let alone like this circle right here is a 1,500-mile circumference. Okay, if you started out driving a car or whatever, you would never notice that you made a circle. You would never even notice you were turning. This line is straight. Okay, if you got down here, remember, this is way down here. Right now we're, even this, we're at an altitude of 3,800 feet. But this line is straight. So as long as you're driving, you're always going to notice that that line's just straight, straight, straight. You would never even notice that when you pull back, you're actually driving in a circle. So that's it. Basically, you go to anywhere that you can want, and this is how they fooled you. They told you, oh, the sun rises for everybody in the east on the equinox. Yeah, because everybody's looking at the equator, and the equator is where the sun is on the equinox. Duh. Doesn't mean that the Earth's a globe. So again, if we draw, now here's the difference. Let me show you where I kind of left this part out. If we go line and we say north-south on a big scale is always north-south. You'll notice 180. Okay, we go save. Now we draw a line back going the other way, and it's going to be 0. We know that because north and south don't change. They're cardinal, okay? So there you go, and we see it'll either be at 360 or 0. We got it close to 360. North and south, if you're standing north of me, I'm south of you. If I'm south of you, you're north of me. No questions asked. Great. So the east-west work the same way? Not at all. Okay, if this person is here in Bakersfield and they're looking east, which is 90 degrees, is going to be down here. Okay, so clearly this person is 90 degrees of that person. Save. So does that mean the other way works as well? No. This person, if they were to look west, is going to look over here. See the difference? So people call me a liar. They want to make up. No, there's no, you were lied to in school, not me. Okay. This is north-south. This is east, and this is west. Okay. Why? Because west is looking at the equator. East and west are looking at the equator. So if you were to draw a line from here, let's say everybody on this line of longitude, let's draw it from up here in Canada, come down this way. Oops, this line. There you go. Okay, so if all these people are looking, let's go west. Let's go east. It's easier. Okay, so we can draw a line anywhere from on here, and I can just tell you where 90 degrees is by going to the equator. Okay, so once I go at the equator, yeah. So once you go to the equator and you look up at your degrees, oops, you can find 90 degrees is right there. There. Okay. So now you'll notice that no matter where you're at, it's the same thing. Now, again, on a very local scale, nobody would ever notice this. It's just how they fool you on a large scale. Okay, so we have that line going that way. So if we start a line here, same thing. We can actually go to pretty much the same exact spot, and it's going to be 90 degrees. Save. Yes. Do it again from anywhere. You do it from the tropic here, right below the tropic. Draw it east. We just go right to that spot and know it's 90 degrees. Okay. And so now you see why everybody. And so if the sun rises above the equator, which we know it does, let's go to bring up the sun. Let's change our date to the equinox will be March the 20th, I believe. So we're just going to go front here. Oops, let me go one down and go to March 20th. Come on, come on, come on, come on, come on, come on, come on. Don't worry, we're at 220, 315, 320. About there. Go back up one. Now we're moving hour by hour. Oops. Nope. Up one more. No, down. Sorry, wrong way. Is that hour by hour? 326. Now I'm a day off. Let's go back this way. No, this way. One touch. Let's move back to 320. 320. There. And then up to get to hours. Is that 1 hour? Okay, that's 1 hour. Then down one to get to. Okay, there. So now we're at 320. So now if you go down and we're right here at this location, and this person was looking east. Remember, this is where you would be when you're looking at your compass. So you're going to look directly east, which is going to be that red line. Now let's get down to the ground level. Stop it. There we go. How's that line above my head? This is the line we're drawn on the ground. Weird. Okay, well, you kind of see that red line's right above our head-ish. So what do you think the chances are that the sun rises there on 320? Let's move up a little bit so we can see the sky. Okay, and then if we take this line and we go sunset, now look where it goes. Well, what do you know? Sun rises, and it's the same for everybody. Okay, so again, the problem is that people get very confused. They think everybody on Earth is looking in a straight line. I don't even get what they think. But no, the east is right there, no matter where you're at. So if you go down south and we do the same thing, it would be the same thing. And if we go up to this line over here, where was our high line? Here. So this person here, again, east is just a straight line from where you're at down at the very bottom. So people don't know that they're looking at a curved line that looks at the equator. That would be weird. They would think, well, how would I do that? But it looks this way. Let's go look up. And there you go. So the sun is again rising at the same spot, 90 degrees for everybody. And then we know that it would set at 270 west, right? So now to that person, they think, because here's the crazy thing. Let me show you one other thing. Hopefully that answered your question. Let's pull back here. So this person here, where was the first line we started from? This one or this one? Oh, we started this one. So if we drew a line here and go from here to 270 west, okay, which is going to put us right in here at the equator. Okay, so that's 270 west. So that's weird, right? Because now if we go look at from above that, around here, try to spin. There we go. Okay, so if we look around that, that's what's weird about it. Look at how east-west is. I'm looking at this cross line here. So we know north-south is, get a little better view. There we go. Okay, so here's your north-south. They stay true, but look at east-west. So now for this person, when they're right here, how would they ever know that? They would look east and they would turn around and look west. It would be exactly opposite of them, right? But it's not, because when you get around and you look west, okay, like this, you see how it's curving around, but this person doesn't know that. This person is just looking very locally like this, about that direction. And so what do you think the chances are that the sun sets exactly at 270 west? Boom. So that's how it works. And I don't know why people don't get it and why they want to argue and pretend like east and west aren't circles. How could they not be? You have to stay around. Now, I admit, yes, on the globe, there's one place that they say is not turning, and that would be the equator. Right? So if you're on the equator, you would not be turning in flight if you were flying straight, so they say. Whereas on a flat Earth, you definitely are, right? But again, how would you know that? It's the most ridiculous big circle you've ever heard of, even on a flat Earth, which I think the equator is about 21,900 miles, 21.9. If that's the case, then you would never notice you're turning. You wouldn't notice if you're doing a circle of 20 miles. Okay. So hopefully that makes sense. See if anybody else has any questions like that. Okay. I found a blind spot line. McTune would debunk this by saying he was in Rome when they built it. Loser. You have a proof of working satellites in your pocket. Oh boy, these people are classic. So funny. Yeah, man, it works pretty much in every remote spot as long as you see the sky. Yeah, because there's balloons up there. We just told you. Yes. We just said that. Again, no cell phone towers in the middle of the ocean. There actually is towers out in the middle of the ocean. They're not towers, they're buoys. But wake up. Stop defending liars. It makes you look like a joke.